welcome back again. I am starting to go ahead and label whichever class you might be in what the unit number would be. So you see if you're in Accelerated 7, it's going to be Chapter 22, and Math 7, it's actually going to be Chapter 13. Regardless of chapter, it's going to be Section 2. Today we're going to talk about the volume of a right prism, which is actually simpler than the surface area. So hopefully you guys will agree with me when we get done that this process is easier than finding the surface area. But I really do think you will. So Misadventure, which always makes me think of Mrs. Yasek, was traveling in Germany, and she decides to buy some cube-shaped candles. So these candles are 1 inch by 1 inch by 1 inch, as we see pictured here on the right. We've got two different boxes that she's able to use, and we want to determine which box is going to be the better choice for her to ship the candles home in. When you travel, you don't want to keep a lot of extra weight inside your suitcase, so a lot of times you will send things home because it's cheaper to ship it home than it is to take it on the plane with you. So, trying to get my smart ink to work here, take a second and think about which of those boxes would fit the largest amount of candles. So kind of draw a picture in the boxes if you need. Draw the lines of where each one, like how much each one would take up. Go ahead and try to figure that out. If you have yet to figure this out, I would go ahead and pause the video. I see that if this is 1 inch tall, then I know that stacking them on the bottom is only going to take up one layer. So I can kind of draw it like that. I know that if they're 1 inch wide, that putting them down here is only going to take up half the width, so I can pack 2 wide. But also, if this is 2 inches deep that I can see up here, then I can pack 2 deep. So really, when I think about how many total there are in here, there's 4 on that bottom layer now. And then I know I can do the exact same thing on the next layer up. So we see that we could fit 8 candles over here. We could also figure this out by using the volume, and look at the volume of this candle is going to be 1 inch by 1 inch by 1 inch, which actually equals 1 inch cubed. Because it's volume, it's always going to be cubed. We could then compare the volume of this shape by doing 2 inches by 2 inches by 2 inches, which actually equals 8 inches cubed. And that also tells me that I can actually fit 8 of those candles in. As we see from the last example, we could just compare the volume, but if I draw the picture, I see that since it's 4 inches, I could actually fit 4 wide. This is only 1 inch deep, so I can actually only fit 1 deep, so I will not draw a cut over here. There's not going to be a cut. But I see I can do the same thing on the top layer, so I can fit another 4. Now let's see if my math works out for that. I have 4 times 2 times 1, which is going to give me 8 inches cubed. So what I see is actually both of these boxes would allow her to fit the same amount of candles in them. When we move on to our first example, we're going to see that we start with the easy prisms and work our way up. You guys, most of you will know your volume formula being length times width times height. Now that is correct. It is length times width times height, but the problem is that doesn't always work out when we don't have a rectangle for the base of our shape, or when we don't have a square. So this is actually not cooperating, so give me just a second to pull up digits through the other method so that you can see this modeled out. So when we look at this, and I'll try to get it to mute, so watch your ears for a second.
You can determine the volume.
So we see that we have this rectangular prism here, and just like we did in the last example, I could section it off. I could say that because this is 4 wide, I can make little markings and say, okay, each of those, that's, you know, 1/4 of the bottom. And this gets kind of difficult, especially if I use dotted lines. But I could draw my lines across here and say, well, what is really the area of this bottom? I see there's 5 wide, so I'd make 5 sections, 2, 3, 4, 5, and see that this bottom area, this is drawn kind of poorly, but the bottom area would be 20. We know that we can find that by doing 5 times 4 would give me that the area of this is 20. And then since I could layer or stack 3 stacks of that, I know that I actually have a total volume of 60 units cubed. Because we're dealing with volume, we always deal with units cubed. Now, that's for any prism, and this formula right here, your big B times H, which you have on your notes, That's the formula that's going to guide us on everything. But big B has to be the area of the base specific to that certain type of shape. So I'm going to pull up your notes real quick to make sure that you are exactly where we want you to be. And so off to the side here, we want you to write that volume is equal to big B times H and notate that big B is the area of the base. Big B has to be the area of the base. Then a cube is actually easier because as we saw yesterday in our lesson where cubes were simpler, when we start dealing with a cube, because all my
You can determine the volume of the...
Because all my dimensions are exactly the same, I know that I'm going to have 3 wide over here, 3 wide right here, and 3 tall right here. So I just do 3 times 3 times 3, or the side length cubed. And you can also change that formula to edge length cubed. So to put that on your notes off here beside the cube, I would say the E cubed, and I would notate that that is edge length. Because remember, E is actually a mathematical constant. We're not using this as a mathematical constant here. We're using it as a variable, so that's why we want to be very specific and notate that that is the edge length. Now the next thing we want to do is try some of these practice problems. So I would actually like you to pause the video and try each of these. The cube is obviously going to be the easiest one, and you'll notice these are the same shapes that we had from the notes from 22.1, but now we're doing volume, not surface area. So make sure that you start by notating volume is going to be big B times H for all of these, except for here, volume will be your edge length cubed. Here, again, it'll be big B times H. And over here on your last one, which I'll have to move my screen to get there. So if you have yet to do it, pause the video, try these on your own. I'm going to go ahead and move forward with solving these. So if I look at the base of my shape right here being that rectangle, I'm going to find big B as 9 times 2, which is 18. I'm then going to plug that in times the height of 3. And we see that our volume, well, we can break up 18 times 3. We can do 10 times 3, which gives me 30. And we can do 8 times 3, which gives me 24. So in total, we get 54 feet cubed. Over here, we have just edge length cubed for my formula. So I can just plug in my edge length of 3 and cube that. Well, if I do 3 squared first, that's going to give me 9, which is still times 3. And 9 times 3 is going to give me a volume of 27 feet cubed. We'll switch colors here. Now my big B is going to be this rectangle, and really we normally look at what shape our base really is by the name of our prism, but since all of these are just rectangular prisms, I could actually choose any face that I want to be the base. I'm especially going to choose the 3x2 just because it's easy. So I'm going to do 3 times 2, which gives me an answer of 6. I then will plug that into my formula, 6 times my 4.2. Remember that 1/5 is actually 0.2. If I distribute that multiplication, 6 times 4 gives me 24, and then 6 times 0.2 gives me 1.2. I can add those together and get a total volume of 25.2 feet cubed. Please make sure that all of those make sense, and if you haven't done one on your own yet, stop the video right now and do this 4th one on your own. We're going to use our same formula, big B times H. I'm just going to choose the bottom side as my base because it's easier that way. So for big B, I'm going to do 6 times 1. Sorry about the smartboard glitch. 6 times 1, and then times the height. So the height is going to give me 9. So 6 times 1 is just 6. 6 times 9 gives me 54. Sorry, that's that bad patch on my smartboard. And I see that my volume is 54 feet cubed. Sorry, I kind of have like a no man's land on my smartboard where I cannot write. Moving on again, what if it tells me, and this is almost the same exact thing as yesterday, except now we're again solving volume instead of surface area. So again, it's a cube, so we use our cube formula. Volume is going to equal your edge length cubed, which again, I plug in my edge length of 3/4, and I'm going to cube it, which cubing something just tells you to multiply it by itself 3 times total. And I can work through my multiplication. My numerators are just going to be 3 times 3 times 3, which gives me 9. My denominator is just going to be 4 times 4 times 4, which actually gives me 64. 9/64, I check if it is reducible. I look for any common factors, and there are none that are easy to see, so I'm just going to go ahead and leave it like this. It's going to be 9/64 feet cubed. As always, please let me know if you have any questions, comments, or concerns at this point. The back is where we start to get a little bit more interesting. So a cube has an edge length of less than 10 units, and the cube has a surface area of x square units and a volume of x cubic units. What is the edge length of the cube? So this is one of those really interesting situations where we see that volume and surface area, although they cannot be equal, because they're different units. One is square units and one is cubic units. So these cannot be the same actually, but we see that numerically they're equal. So we need to determine what the edge length is. And notice we're dealing with a cube. So think about yesterday's surface area formula. Well, we're going to do surface area equal to our volume. And surface area we saw was 6 times the edge length squared. Volume was the edge length cubed. So I'm actually going to write out that this is really 6 times E times E, and this is E times E times E. Well, on both sides, I look at what could I do to cancel things out. Well, I could get rid of the E times E by dividing by an E squared, or just showing out the E's written. So these cancel, these cancel, these cancel, these cancel, and what that shows me is that my edge length would have to be 6 in order for this to be true. Very interesting situation there. Again, those surface area and volume are not actually equal because they're not the same type of measurement. One is square units, one is cubic units, but numerically they're equal, and that allows me to solve that interesting problem. Go ahead and try these on your own. Pause the video if you can. Pay attention that this is a triangular prism, so my base is going to be this triangle over here. And remember that the area formula for a base, or sorry, not a base, for a triangle is 1/2 the little b times little h, and little b and little h must be perpendicular to each other. So if you did not remember that right off the bat, you should write this out, that little b and little h have to be perpendicular. So when I'm looking for my big B, that's going to be the area of my triangle. It's going to be 1/2 times little b times little h. That little b, I'm going to actually use 12 as my little b because it's easier to chop in half. So this now becomes, half of 12 is 6, times 5 is 30. But again, that's only my big B, so now I have to plug it into my formula. Volume is going to equal the big B times the height. So it's going to equal that 30 times the height, which is always the distance between the bases, which here is a 17. I can break this up and do 30 times 10, which is 300. Then 30 times 7, which is 210. Add those together, and I'm going to verify this in my calculator just to check, but our math is good. This would be 510, and because we don't see a unit, we can just say units cubed. Pause the video and try the got it on your own. You want to make sure that you can solve this on your own, and you need to be showing out your work in your notes. You cannot just copy down the answer. You've got to have this whole process shown. So we start by making sure that we list out the formula that's going to be used for this specific big B. We always want to list out our formula for volume just because we want to remind ourselves the more times we write it, the easier it is to remember. So try the got it on your own. If you've not done it yet, pause the video, try this first. We see here that our big B is this triangle on the bottom. We see that it is an equilateral triangle told to us here in these details. So when I set up my 1/2 little b times little h, well, I know that this bottom edge must be the same as every edge, so that one's labeled. But don't fall into the trap. I don't want one of the other edges. I want the height of the triangle, which is this line that comes perpendicular off the base. So that is 3.5. Sorry about the smartboard issue there. So then 1/2 of 4 becomes 2 times the 3.5. I like to do my multiplication slowly so I can see all my work. And that comes out to be 7. And because that's an area, that would be meters squared. It's good to notate that that's your big B. Now I'm going to utilize my volume formula, which is the big B times the h. That's going to be 7 times the height, again, is distance between the bases. Here, most people start to have an issue with seeing that the 11.6 is the height, but we say height, but we're really always referencing the distance between the bases, and the bases have to be the identical shapes on both ends of your prism. So we see here it's that triangle, so my distance between them is 11.6. I could do 7 times 11, which is 77. I could do 7 times 6, which is 40, well, think of 42, but it's really 4.2. So I combine those together and I get 81.2. Again, I have to use my label, meters cubed, because it's volume. Please let me know if you are having any questions, comments, concerns, any struggles on this. Hopefully you do agree with me at this point that volume is an easier strategy than surface area. Just like what we did in surface area though, now this gets a little complicated because my shapes are not easy shapes to solve. When I have hexagons or pentagons or anything really bigger than a 4-sided shape, I have to first break it up into triangles. So our method here that we use is to think about how many triangles this shape would actually have. I see that it's a hexagon, so I would have 6 identical triangles. So to find big B, it's really going to be 6 times the triangle area. So I first want to find that triangle area, so I'm just going to use A for my triangle area. It's going to be half the base side, which is a 3, and the height of it I see is 2.6. Half of 2.6 is 1.3, and then I multiply that by 3 just because the multiplication is a little easier. That's 3.9, and now to find my big B, I got to multiply that by 6. And we see that our big B here comes out to be 23.4. We're then going to use that value with my height of my prism. Again, it's always the distance between the bases. What's the distance between the hexagons? That 4. So my volume is going to be that big B. I'll write the formula first. Big B times H, which is going to be 23.4 times the 4. And the volume ends up being 93.6. Again, we got a label, inches cubed. Smartboard's getting a little weird, but make sure that you have a decimal point there with your answer. Pause the video and try the final got it on your own. You want to make sure you break up that hexagon into triangles first to solve that area. I'm actually not going to solve this out. I'm just going to show the solution page. So pause the video. Try this on your own. If you have yet to do so, please do so now. So there was our solution from our first one. If you want to run over that again, this is not the got it. This was our first one. And they then tell us to approximate and round, so they get approximately 94 inches cubed. We, on our second one, have this hexagonal prism. We see that the hexagon has to be the base. So we break this up and do triangles first and think about that math. So the process that we take there will look something like this. We do 6 times the area of one of the triangles. We find one of the triangles areas by using 1/2 base times the height. Plug in the 6 and the 5.2 because I see here the base of the triangle is 6. The height of the triangle is 5.2. So then as we move down, once we find that value, multiply by 6, and then we multiply it by the height or the distance between them, which is that 10.9. So that's where we bring in this 10.9 to be the height, and we get then approximately 1,020 meters cubed. That is everything from your notes. So hopefully you've got those completely filled in, because again, we're going to do another notes check at the end of this unit. But if you have any issues with any of the volumes of Prisms, please let me know either on Schoology or come see me. Thank you guys. Give the practice work your best shot and let me know if you have any issues. Have a great day.